Another operation we can perform on vectors is adding them together in vector addition, but because each vector may have its own direction, the process is different from adding two numbers. So the most common graphical method for adding two vectors is to place the initial point of the second vector at the terminal point of the first. So let's scroll down to the figure that they have drawn out. So we have our vector v here on the left and vector w on top, and they're forming this rectangle, right? And so we've taken our vector v and at its terminal point, we've placed the initial point of w. And so in red is what we see is their addition. So it's pretty different from normal addition of numbers. All right. To see why this makes sense, suppose, for example, that both vectors represent displacement. If an object moves first from the initial point to the terminal point of vector v, and then from the initial point to the terminal point of vector w, the overall displacement is the same as if the object just moved from one initial point to the terminal point of the vector v plus w. So we call this approach the triangle method. Notice if we switch the order so that w was our first vector and v was our second vector, we would end up in the same place again. Isn't that interesting that if we place that blue w first, maybe on the bottom, and then place the v up at the top? Let me go ahead and write these out as well. Okay. So, an operation we can perform is vector addition. Okay. So the triangle method says to sketch one vector, then place the initial point of the second vector at the terminal point of the first. Right, and so that will give us our sum. So I'll just kind of sketch out the example that they've given us here. So here's our vector v. Let me go ahead and make sure my initial point is clear. Right, and then if I have my vector w, then what I can do is basically just map this point and move things around, right? Because it doesn't actually matter where the vectors start, as long as they have the same magnitude and direction. So there's my vector w. And so this is my sum, right? Here's my starting point. I've done my vector v and I've added to it w, and this is where I ended up. So this in green is v plus w, if I could only get a straight line. Interesting, and we could do the same thing starting with w. That's why we create this rectangle. Okay. So a second method is called the parallelogram method. So with this method, we place the two vectors as they have the same initial point, and then we draw the parallelogram. Interesting. The vectors as the two adjacent sides. The length of the diagonal of the parallelogram is the sum. Okay, so I kind of actually already did that, right? So this is our figure B. We're saying, okay, so we've got this V and this W. So go ahead and finish drawing out the rectangle, and whatever you end up with is going to be your sum. Cool. So this is our triangle method here on the left. And then we have our parallelogram method, which is basically exactly the same. All right. Place the two vectors with the same initial point. draw the parallelogram. And the diagonal of the parallelogram is the sum. Okay, so the sum of two vectors v and w can be constructed graphically by placing the initial point of w as the terminal point of v, and then the vector sum is the vector with an initial point that coincides with the initial point of v, and the terminal point that coincides with the terminal point of w. So this operation is known as vector addition. Fantastic. So we've kind of already talked through that entire definition. So I'll just kind of add that little bit there. All right, let's see what's next. It also is appropriate here to discuss the vector subtraction. So we define v minus w as v plus negative w, or v plus negative 1 times w. So the vector v minus w is called the vector difference. And so graphically, we're going to draw the vector from the terminal point of w to the terminal point of v. Okay. So where do I have it? Right there. Okay. This is our vector difference. So v minus w is defined to be v plus negative w, which is v plus negative 1 times w. All right, and so what we end up with is that if we have our vector v and we have our vector w, right? Well, we said that negative w means that basically what we're doing is flipping it, right? So negative w would have the opposite direction but the same magnitude. So v plus negative w, the way that our addition works is that I'm going to take this w, negative w, up to the point of v and make sure everything's parallel, right? So this is our slope. There we go. It's not very nice, but there we have it. So then we're starting off at our point v, and then our terminal point is the tip of our negative w. So in green here, I have v minus w. Cool. Or in red in the textbook. All right. So the initial point of v plus w is the initial point of v, and the terminal point of v plus w is the terminal point of w. These three vectors form the sides of a triangle. So it follows here that the length of any one side is less than the sum of the length of the remaining sides. So now we have our triangle inequality, right? So basically what this is saying is that when we're doing our vector addition, sure, we're changing the direction, but we're also changing the magnitude. And what that magnitude equals, well, it looks bigger than v and bigger than w, but it's not quite v plus w, right? So now we have another rule, the triangle inequality. Right, and so this says the magnitude of v plus w is less than or equal to the magnitude of v plus the magnitude of w. There is one case, however, when they are the same, and that only happens when they have the same direction. So just kind of a note. And for some reason they use u and v here, and that's fine. We can change our letters. So the magnitude of u plus v is equal to the magnitude of u plus the magnitude of v, if and only if the magnitude of u is, I'm sorry, if the direction of u and v is the same. All right.